Hello and welcome to BSD TV. This is a video of Ori Bernstein's October 2019 NICEBug meeting entitled Plan 9, Not Dead, Just Resting. Ori is someone I've been running into at BSD Cans over the last few years. This current West Coaster was nice enough to stop by the New York BSD Users Group, and for the true New York experience, we got a visit from the New York City Fire Department during his talk. Thankfully it was a false alarm and Ori's talk was a success. Well attended with lots of new faces and engaging questions. Enjoy.
I'm going to be talking about Plan 9, as you can see. So a summary of what's happened to it, or what's happening with it, why you don't want to use it, why I use it anyways, and generally the state of the union. And, of course, what people can learn from it, even if they're not using Plan 9. So, it's already been covered, but feel free to interrupt me at any time. If there are any questions, I'd rather go off track or go and beat around the bush a little bit rather than just lose people or bore people. So just feel free to stop me, ask questions. So who am I? What do I do? Why Plan 9? So yes, I do have a Plan 9 laptop. It's that one over there. This one's actually running OpenBSD because I don't trust Plan 9's dual monitor output. Working on it. This one, but I am running this presentation remotely over Plan 9. So you're getting the real deal. I use it regularly. I actually write code on it. I log into other systems and develop code from Plan 9 sometimes. And yes, that probably means there is something wrong with me. I am definitely way too stubborn. Okay, so why don't you want to use Plan 9? Well, it doesn't have the programs you want. This came from the 9fans mailing list years and years ago, and it details a typical new user's experience with Plan 9. Hi, I'm new to Plan 9. I'm really excited to work with this new Linux system. I have some questions. How do I run X11? Where is Emacs? The code is weird. It doesn't look like GNU C at all. Do the people who wrote Plan 9 know at all about C? I tried to run Mozilla, but it didn't work. How come? You can tell this is an old post because it refers to Mozilla. Anyways, sorry, there is no X11 asterisk. Plan 9 does its graphics through the dev draw device, keyboard FS, dev mouse, and Rio. I'll go into a bit more detailing on that. So that star actually is because the slide went out of date this September. Someone actually got an old port of X11 working, and you can now basically run X programs on a Unix machine and have them display on Plan 9. Although, amusingly enough, we got Chrome working before we got Xclock. Yeah. Yes.
So, Plan 9 has an SSH client?
Yes.
Can you do SSH exporting over SSH?
I don't believe so. I don't think that the X forwarding channel has been implemented.
Yeah.
So this is the Emacs man, and I'm not joking.
That's the man page?
That is the actual man page. There is no Emacs. There is a man page for Emacs describing why they don't, making it very clear that they do not like Emacs, and it was intentionally left out. There is VI. That's not the right VI. VI is a MIPS emulator. Someone has ported Vim, but I've never actually tried using that. The web browsers are, to be blunt, crap. You have two web browsers shipped with the system. One is called Mothra, one is called Abaco. I will show them to you. They don't do Chrome, they don't do CSS, they don't do JavaScript. Yes, they do. Everything does HTTPS because the browsers don't actually do HTTP. You have WebFS that does HTTP for them. This is Mothra. Oh, I have not started WebFS on this thing. This is how Google looks on Plan 9.
Well, that's pretty good.
It's actually kind of usable.
It beats Dillo because it has TLS.
Yeah.
That's the, like all the. In order to use the internet these days, you need to use one of those garbage browsers like Firefox because the other things don't support TLS. Well, they can technically, but this does. So
Yeah.
Go to Nicebug, maybe.
yeah, that's
Sure.
Ooh, yeah.
Sorry to be thinking about me.
Nicebug.org.
If you really want to be adventurous, you can stream the stream.
That's not going to work for sure. That's actually not bad.
Yeah. It's pretty good.
Yeah. I can actually use that.
It's like it renders simple HTML. It won't render anything.
Well,
No, it will not.
So it's actually a standards compliant browser, relatively. For
Yeah.
all standards.
Yeah.
Out of curiosity, let's see DuckDuckGo in here.
DuckDuckGo. Okay.
Oh wow!
Yeah,
Wow.
They've got a version that if you try to use it off.
It'll display
Well,
something.
they have no JavaScript version, I know that.
Yeah.
It goes that concept.
Anyways,
So,
so that's the web browser situation.
Yeah.
You probably don't. That probably kills a lot of the usage. But so that's what Plan 9 isn't. It's not a system that you can that runs your modern programs that you expect on Unix. It's not POSIX. It doesn't. Anything you want will probably be. There's a POSIX emulation layer, but it's not very good. Porting is a chore. A lot of the time, it's easier to run your own, or to write your own. So it's not a Unix system, but it is a Unix-inspired minimalist distributed graphical text-oriented research operating system. That kind of covers most of it, but it's a bit of a mouthful. So let's break it down. Well, the short summary, slightly more facetiously, is imagine all the good things they told you were true. The good things they told you about Unix were true. Well, so first off, it came from Bell Labs, so it's got the same sort of design aesthetic as Unix. Very minimalist, very text-oriented. Everything's designed around hierarchies of files. But it's also, it's minimalist, so much more minimalist than Unix. You've got 50 system calls. You've got a much smaller number of programs. And things are kind of put together by assembling namespaces. It's Unix-inspired, so it's for many people it ends up kind of in the uncanny valley of Unix. It's kind of like familiar, but not really. Imagine your mom going for plastic surgery and coming back. She looks kind of similar, but there's a difference. So, distributed. Most of the time, people use the word distributed to imply fault tolerance, resilience, and so on. So I kind of hesitated using this word here, but it is a distributed system. The parts of it are not all on the same machine. So draw term is what I'm using to remote into that box. And the way it works is actually by, sorry, I'm a little bit sick, by pulling in parts of that system's namespace into this machine. It's actually basically a stripped down emulated Plan 9 kernel running in user space that does the remote login. So it's kind of a crazy way to do it, but it works. And of course, you build the system by pulling in resources from other systems. I'll go into more detail on that later. Graphics. So you can't actually use Plan 9 effectively without graphics. The way that Plan 9 is designed, you really want to have some sort of graphical terminal so that you can actually do things. The command line without graphics is extremely, extremely variable. It doesn't give you command line history. It doesn't give you line editing, so you can't actually mouse arrow back and forth to edit the text you've already typed. It doesn't give you really anything because that's all being pushed into the Windows system. So any text is managed by the Windows system. So for example, you can see ls. I've got that listed. I can click back here and edit the scroll back. And that's how you do the line editing. If you want to, let's pull up acid. I don't care, I'm just getting some stuff into the history from outside the program. And then quote pulls up history. Not easily. Yeah. And you can see I'm actually looking through dev text and I can find the previous lines. The quote script is used for rerunning command line programs. I forgot that it actually looks for the prompt in the front so it filters out the. So the demo didn't quite do what I wanted, but you can actually look through all the command line history, poke at it, and that's done through the Windows system, not through the shell itself. Okay, so graphical, text-oriented. As you can see, everything's graphics, but all the graphics that it's showing right now are text. Everything's designed around manipulating text, splitting lines through text, and so on. And it's kind of designed around, well, the entire point of all the graphics is to make it easier to deal with text. It's also a research operating system. So the design of it is, part of the reason it's so simple is because it's a lot easier to mess with the system if you don't have tons and tons of ossified history. It comes with a bunch of research papers. Here I can actually make the font bigger more easily. Oops. Let me just type a new button. Oh yeah, yeah, sure. You can type buttons here. If I want to type a new window.
So you're doing the formatting up there? I can't see.
Yeah, so the, yeah, this is annoying. I accidentally deleted my font size setting. Okay, so it comes with a bunch of research papers. And so just to summarize the differences, for graphics, instead of X11, you've got Rio, which is the Windows system. Instead of Bourne Shell, you've got RC. RC has a lot of useful features on top of Bourne, like having lists, so you don't have to worry about word splitting, killing any script that has spaces. This is probably the most useful change in RC, but overall it's a much more regular and less quirky syntax. The editors, you get Sam and Acme instead of Emacs and Vim. For password management, you get Factotum, which is kind of the equivalent of SSH agent, and Sextor on an auth server, which actually securely stores your password. X11 is replaced with KeyboardFS, Draw, Mouse. NFS, you get ExportFS over 9p. So that's the details of that. And a whole bunch of innovations that came out of research on Plan 9 include UTF-8, which was apparently done in a diner in New Jersey.
Seriously?
Yes. Yeah, seriously.
Wow. Jersey represents.
Yeah. Basically, the story is, there's a much better summary of it than I can give right now online, but in a minute or so, they basically looked at what some standards body, I think IBM, was proposing, went, this isn't very good, let's do it better before they actually ratify the standard. So they did, and now we have UTF-8. The proc file system on Linux, that came from Plan 9 indirectly. Ported of compositing, which is the whole drawing with transparency and so on. Plan 9 did that first. The X11 Xrender extension explicitly mentions Plan 9 as the inspiration. Namespaces like you'd use in Docker, those came from Plan 9. Communicating sequential processes, so for example, the communication model of Erlang and Go. A lot of the initial implementation came from the Plan 9 research environment. It's not the only place that happened. Tony Hoare did not work on Plan 9, but it's one of the places where they really started experimenting with it. It looks like you're taking a picture, so I will pause. Okay, all right. So cool. And that's what happened at Bell Labs. Bell Labs died. So what's happened since? Well, there are a bunch of forks. There's 9 Legacy or Plan 9 Contrib, which is really a collection of patches. 9 Atom, Harvey, 9 Front, Akeros, Nix, Plan B, Inferno. Probably more forks than users at this point. Maybe. Actually, I don't think that's true. I think there are more users than forks. But I wouldn't bet on it. Anyways, so quick summary of what these forks are. There's 9 Legacy, which is essentially a patch collection for the Labs version of Plan. So they're not taking and really modifying it too much, but they are collecting fixes, new toys, new hardware support, and so on. They're keeping the most important patches in the Git repo. The rest are just kind of apply as you like. 9 Atom is, again, same. It's taking the Bell Labs stuff. They're not really touching the artwork, but they are just adding some hardware support to it. I'm not sure what the current status of that is. The site seems to be down, but these things come up and go down as stuff happens, and I believe 9 Atom is just one person. So there's Harvey, which is more modern, more Unixy. They're trying to actually make the POSIX environment good enough to run Unix programs without spending weeks porting them. They're trying to move the compiler suite to GCC and Clang. They're trying to hook it up to, I don't remember. I think they're trying to add the sanitizers, all of the nice toys. There's Akeros, which is a research fork that the University of Berkeley maintains, and they're basically trying to do multi-core, exploring a bunch of new ideas, trying to figure out how to make multiprocess a more native concept. They're doing some neat stuff and pulling in a whole bunch of Linux bits as well. I think they've started using RCU for performance sake within the Plan 9 kernel instead of locking. RCU is essentially read copy update, which is lock-free multi-reader single writer concurrency. I can go into more detail about that later if people have questions, but I'm not going to go too deep into that. There's Inferno, which is another, it's not really a fork, it's another interesting OS designed around Plan 9, but it's runnable on top of other operating systems too. So if you want a Plan 9-ish system that you can run on top of Windows, Mac OS, Linux, Plan 9, and so on, as well as on bare metal, even down to machines with 1 meg of RAM and no MMU, they do that. They've written that in Ringo, which is a JIT compiled language, kind of like, which runs on something vaguely like the JVM. It's a neat system. I haven't done too much with it, but yeah. So that exists. And then there's 9Front, which is the one that I use. It's actively maintained. It has great hardware support as far as these things go. So by great hardware support, I mean I can pick, say, ThinkPads and not spend years and years of digging to find some sort of supported hardware. Like, I'm using an X260, I've got Wi-Fi, I've got native resolution, and so on.
Are they writing native drivers, or are they using binary blobs?
Native drivers.
So they barely have enough users, but they have developers who are writing
Yes.
reverse engineering or taking open source drivers, like the open source hardware, or
the hardware support is still it's not giant, but as far as these things go.
So I'm sorry, what are the chipsets? Not to drill into this, but I'm just curious. Which ones you support? Do you know?
Which chip? Wi-Fi?
Yeah, Wi-Fi.
It's basically the Intel chips.
The Intel. Okay.
Yeah.
IWA.
Yeah, I think it's IW. There are some ancient ones that are supported. I've got a slide on that too. I should show you. So most of the 9Front developers, or the main ones, are German. So of course I have to show you the German engineering. Oh yeah, I middle click on that, and that I said text oriented. It knows it's PNG. It knows where the PNG is, and it goes, okay, I should open that in the PNG viewer.
I thought it was a hard copy picture you put on the projector.
No. So basically, the plumber is a neat another neat piece of engineering. Basically, what you do is you send it messages. It looks at the message and goes, so what can I do with this text? Is it a C file in my current directory or a C file that I can know about? Let me open it in the editor. Is it a URL? Let me open it in the browser. Is it a message from the email program? Okay, I should show a notification that you've received mail, and so on and so forth. So it's all text-based. And you just, in this case, middle click on it, and it just says, okay, do your thing.
Can you do it without a mouse?
No, not really. There's
So
not.
it's not just file association. It's actually looking at the file header
It can, yeah. It can.
beyond just like, oh, this is a PNG open as picture. It's more than that, right?
You can do that, I believe. You can basically attach any arbitrary script.
But you can do it in AOS.
Yes.
But it's at the level of the windowing system that recognizes it. It chunks it into the file name. It's not within the editor.
It's not within the editor.
It's not, and it's not like strictly like path specific, is it? Like as long as it goes through the file system and finds like a file that says German engineering.png and just says, okay, I found it, open it. Literally modify it.
It's just like using Magic Point as an operating system.
Yeah, it's like you literally modify it right there on the spot and just add new things to it. That's cool.
It's small talk.
Okay,
Yeah.
here we go.
Very small talk.
So here are the rules for the plumber. Oh, and I just broke my font. Oops. Anyways, you can see the kind of how they do it. Type is text, destination is MS Word, plum to MS Word, start Word to doc file. Email addresses get a new window, plum start, etc., etc. So it can match email addresses and say, do that. Okay. So let me restart my font server. Let me delete this file and then restart my font server. And now fonts are back. Okay, so, oh yeah, so German engineering PNG. Anyone know what the photo is?
I'm guessing.
Is that the LHC?
No, that is the inside of the Hindenburg.
Oh wow.
They have a sense of humor.
I
Anyways,
don't know who they is, but it probably was the Germans.
It was the Germans. And Hindenburg had actually really good.
yeah, so hardware support. It's actually got pretty good hardware support.
It was literally just chemistry that did it.
Yeah. So, yeah.
I was gonna ask if
Better
anyone says
desktop
hardware support. It's better or worse than Illumos?
for the most, I've heard rumors that it's better.
Better.
I don't know for sure, but it actually has hardware support. I can run it on my hardware. Most of the time, as long as I don't care about Wi-Fi, I can toss it on most hardware and it'll just work, at least with VESA drivers. So going into specifics, there are Wi-Fi drivers working on multiple cards, mostly Intel ones, and I'm using them right now to talk to that machine. Intel native graphics drivers, up to Haswell. They were written in, I believe, a week.
Wow.
Why is it easier?
Part of it is that we don't care about 3D graphics. So, yeah, if you don't care about 3D, all you really need to do is tell the graphics card, hey, I want this this area of memory to go onto the screen, and then you draw into that.
So I'm guessing this means that Plan 9 does not in fact run Doom?
I don't have any data for it. But it does have Doom. It ships with
It
it.
has Doom?
It ships with it.
You did. Is able to play.
The ultimate test.
It's a Quake port too.
Is there a Quake port?
Yeah.
Oh, that's not surprising.
It's so 1994. I love it.
VMX, virtual machines. You can run OpenBSD on Plan 9 if you want. It's slow, but it exists. I see someone going, why? Well, if you happen to want a modern web browser that can do JavaScript, then you want to have an OS that can run a modern web browser that can do JavaScript. So for that, you need virtualization. There are other reasons too. You want to be able to test your kernel without actually rebooting the machine and debugging it and so on. But yeah, having a virtual machine is super useful, and it even runs ancient versions of Windows, I think. And the forwarding for Wi-Fi bridging, that's done with Matt Damon. The Matt Damon. It bridges your Ethernet for you. Don't ask me why it's called that, but NVMe is supported. That was done in 1 weekend. The Synap, his actual name is Friedman Gerald, but I think everyone calls him Synap because that's his nickname. He is insane. He is a machine for turning data spec sheets into code. When I tested out his NVMe driver and started using it, it didn't work. We started debugging it. I figured out why. The drive didn't conform to spec.
Right, but wireless is probably worse.
Wireless is
Specs versus writing the
Yes.
file, right? I mean,
well, yes.
yeah.
Wireless is complicated, and also there's a ton of chipsets. TTM. So I'm using that right now for this display. It works, hinting and all. It's independently developed. It's about 5,000 lines of code. It does a whole bunch of. Oh, sorry. Why is this not plumbing? Oh, it probably is plumbing to the other window. Yeah, but it's loading it. So
There it goes.
you can shape it. You can do that. Plumbing that. Why is that not plumbing? Let me just try one more time. Yes, no, maybe. Nope. Okay. Let me figure out why that. I might not have that file in that. Okay. Maybe I forgot to copy that file. I'll dig into that later. But it does Asian text too. So nicely laid out. CWFS is the default file system. It does snapshotting and lets you look through the history of your files. So for example, I can do local 9fs dump. That loads up, that mounts the dump, and then I can look at my files from 2018 or 2019. I don't know. And yeah, well, they've got support for it. And here's my code. Way back then, I didn't have that much code sitting on that system. But yeah, you can dig through the history of your files. By default, it takes a snapshot every night. And it's had this since probably about the 80s. Or early 90s, I guess. Git 9, that's my baby. So I've implemented I've done a complete Git implementation for Plan 9 from scratch. Lets you do all of the usual source code management stuff that you need. It's kind of file system based, does the init, push, pull, export, import. It's got a clean, easier to use command line interface than upstream Git. I'm not doing the clone. The upstream Git's UI is terrible, so let me do something good. To give you an idea of how the kind of things that you can do internally, here is the full implementation of git merge. That's all. It's just a shell script. All it's doing is looking at which files, which branch you want to. Well, it starts by mounting your Git file system, decides which branches you want to merge, then walks through the file system's view of the Git file system's view of the data on that branch, the Git file system's view of the other branch, and just uses the diff3 command line utility to merge them. You don't need that much once you can actually access the data from your command line. Okay, so cool. But big yawn. You've already got all of these features. Why the hell do you care? Because you've got Unix. It does this. What's the point of all this shit? Well, the thing is that all the features that Unix has are nice, but the power of Plan 9 actually comes from something else that you can't get by adding features. The power of Plan 9 is, the essence of Plan 9 is 9p in namespaces. And that's essentially how you put the system together. So 9p is the Plan 9 file system protocol, and namespaces are essentially views into the file system. Every window has its own namespace. So here is the full list of operations you can do in 9p. There isn't anything else. All your communication with the system goes through this. The only things you so all the system calls map to this or process management or namespace management. So you have your data access and manipulation, you have fork exec, and you have mount and bind. And basically that's, and nsec, which gives you the current time. Those are your system calls. Everything else is done through this. There's no other way to talk to the system. Now, this is a network protocol. And because the only way you talk to the system is through the network protocol, everything becomes network transparent for free. Namespaces are the way that you manage the view for all your programs. This is essentially the way that, this is a view, well, a short snippet of the namespace for the current process, or for a no longer current process. So you take and this is from a remote log. So mount term is your remote system. Mount term's devices are mounted over your local devices, in this case, which means that opening dev draw on this machine, or on that machine, opens it on this machine. So a program that says, I want to draw something to the screen over there, gets redirected here for free. There's no code in that program that needs to know. /proc is /proc. Hash devices like this are magical bootstrap things. So you can, so you basically get a magical hash-p device which you can bind into your namespace and start using it. Same with the pipes. Rio is your Windows system, and you kind of assemble any process's view of the system around it from these namespaces. But even then, this is cool, but it's not about 9p. Who cares that you're using this specific protocol? It's about using unified mechanisms that you can interpose. And that's really the lesson that you can take from Plan 9 and port to other systems. Pick one way to do something, and then once you've picked that way of doing it, you can make sure that you can replace the component and put a layer in front of it, and now you've got a massive amount of flexibility. This is also why you can't take features from Plan 9 and move it to Unix, because adding one more way to do things to Unix will not give you the ability to put a layer in between and intercept or rewrite or view all the operations that a program can do. So on Unix, I can't put in a interposer for dev draw or dev mouse or dev keyboard and rewrite or change the change dev keyboard to say add in input methods for Japanese input easily. That has to be specially hooked into all the programs because there is no unified way of doing it. And all the features you want, unless you manage to guarantee that no one's using them anymore, well, then you just can't. So
Well,
It's-
so yeah, that
yeah.
level, yeah. But there's other things that people have. I mean, all the BSDs have a bunch of Plan 9 ports, right? I mean, there's
Yeah.
other
you can
user land layer tools that are out there that are ported, including the C compiler.
sure. I mean, you can definitely get into Ubuntu with the Plan 9 theme.
Yeah, well,
Okay, so the essence is
I'm
really
not going to take the bait on that.
okay. You can get a free BSD with the Plan 9.
Well, I mean, no, but I mean, I brought this up earlier, but like, I know when everybody was all hot on PCC as a replacement for GCC years ago, 15 years ago, whatever, there was a lot of talk about how Plan 9 C compiler was, doing a lot of wonderful things that people would love to have.
And sure, that's true. There's a lot of good stuff in Plan 9 user space, and but those are just features that you can port. I don't think that they're really the core idea of Plan 9.
No, it's a fundamentally different operating system.
I agree.
Yeah, of course.
Yeah. But anyway, that's my point. So, so things that are happening outside the Plan 9 world, gRPC, it sucks, but it's great, and Google's using it everywhere, and it gives you the same kind of, at least if you're at Google, it gives you the same kind of one interface to all your systems. Some places do the same thing with REST, and that kind of thing is, really helpful. Docker, it's got the same kind of thing. It's a really nice way of managing your namespaces, putting things into little boxes, but it also sucks. So 9p, I still think it's better than these guys because it's universal. So Docker, gRPC, all the other tools on other systems are universal by convention. In other words, people kind of shut their eyes and go, no, nothing else exists. But on Plan 9, 9p is actually the only way you can talk to the system. And the other nice thing is that it's actually implementable by humans. So when I was working at my last job, we ended up using 9p for some firmware interfaces. And yeah, we didn't get the universality, but it's a nice way of actually connecting to firmware and modifying it. And it's was something like 500 lines of code to implement.
So right now, just to clarify, you're talking about 9p not on Plan 9.
I'm talking about 9p on, 9p being universal is on Plan 9. 9p being implementable by humans, that's all over the place. For work, I was not using it on Plan 9.
Okay.
That was sitting directly on STM32 and bare metal implementation, 192 kilobytes of RAM, etc., etc. And then we were talking to Linux. We were talking to that firmware through Linux using a user space implementation of 9p.
Did your colleagues know what you were doing?
Yes.
Wow.
So I think that's the one thing that made them go, this Ori guy has really weird ideas, but they always seem to work out. And then they just started letting me do what I wanted. At one point, we were trying to figure out how to do RPC within Linux, ignoring not to the firmware. And I wasn't even in the room when the CTO suggested we use 9p.
Makes you feel better. What is gRPC?
Sorry?
What is gRPC?
Oh, okay. gRPC is Google's RPC protocol. So, yeah, gRPC. It's basically protobufs. Have you heard of those? Yeah, okay. It's a way of describing this service takes these messages and has these functions you can call. Yeah.
It makes you feel better if Google's newish hypervisor, gvisor, is sitting on top of 9p implementation. So like the protocol is getting used in this kind of like places.
Yeah, it's actually kind of weird how 9p seems to become the not traditional, default implementation for connecting the native OSS file system with a virtualized machines file system. Now, to be fair, it's a very heavily extended 9p. So 9p is basically Ken Thompson's idea of this is what a VFS should look like. And then, so it's got these many operations. 9p for virtual machines has got these many operations. And it's all the stat stuff, all of the mmap, et cetera, et cetera. But it's still there. So for example, you've got /net instead of sockets. So on Unix, you have a whole bunch of special system calls for creating sockets. On Plan 9, you have netTCP clone, which creates a new connection. And then that gives you reading the clone file descriptor lets you control the connection, also tells you, okay, so your data is sitting over here in the netTCP 0 data. And that you open that file and start doing I/O on that to do your TCP, which is nice.
As opposed to syscalls.
As opposed to syscalls.
Okay, so isn't there a real problem with giving fine-grained control over syscalls then?
There
in
aren't
that case?
Well, there aren't that many syscalls, but
right. But so I need to give an application, needs to talk TCP for anything. All of a sudden, I'm giving one syscall.
Permission.
Sorry?
It's a file, so it's permission based.
Yeah.
Right, but I'm giving away like everything. I'm giving it a lot less fine-grained control than I would with syscalls, right?
Well, with
the assumption is that if you have limited syscalls, one syscall does a lot more than a Unix system.
One syscall lets you do more things, but you have the control to, to basically allow opening a TCP socket. If you don't want TCP sockets, don't put it into the process's namespace. Now, at the same time, there's no firewall, so you can't say, I'm only allowing TCP on port 443. But that's an implementation issue, or quality of implementation issue, not a fundamental limitation.
Yeah.
What you could do, if you really wanted to, was well, I'll talk a little bit more about that in a second. It might even be in the next slide. Okay, no. So this is actually a shell script that opens TCP connections and starts talking on IRC. What you're doing here is a whole bunch of file descriptor manipulation saying, start by figuring out who you're talking to. So the address is the second connection. /net is the network stack you happen to want to use. Do IRC and nickname. Do IRC would be your script that actually does IRC. And so you start by dialing it using NDB CS query, which basically looks it up. And then you basically run your command. There's nothing too special. The only trickery here is that you need to actually keep the script running so that the file descriptors don't go away when the command disappears. You can do something vaguely like this on Unix, except you can't open net data. You'd need to write a special program that does TCP. This is manipulated entirely through the shell script. Now, there's more. You can actually interpose your own network stuff. So SSHnet is a program that takes it's a file server. What it does is it takes the network stack it emulates a network stack, but instead of doing networking locally, it tunnels it through TCP. So this is an SSH proxy that programs don't know about. Basically socks. TunTap, I guess, is the closest script you'd have on Unix, and you can do SSH through that. This is just namespaces and 9p. And if you wanted to restrict ports, well, I would do it through something like this, where you'd have a program that basically puts itself between the network stack and your program and says, no, 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 no. You're trying to talk on port 444. You're only allowed 443. Goodbye. So there's more. If you want to use instead of network address translation, you can just mount someone else's network stack and put it on top of yours. So now you can just tunnel your network through it. Again, namespace is in 9p. You don't need any special support in your programs. You don't need any special support in your operating system. All it is mount, basically. So Rio is doing the exact same thing, except with DevDraw. So DevDraw is actually the entire stream. And what Rio does is it says, okay, let me split that up into rectangles. Each program thinks it's got its full DevDraw, full stream. Rio just kind of creates a virtual one and splits things up. It does the same with mouse and keyboard and multiplexes in between the windows that it's emulating, so you can actually run Rio within Rio and it doesn't know. Programs don't like, well, yeah. It's a slight lie to say programs don't care. There's extra information that Rio gives them, like the window name and so on, which you can set. But for the most part, it's the same DevDraw, same drawing protocol as anything else. And hell, even this slide. So the script here, this is my slideshow program. I have a text editor that actually looks at the slide list and manipulates the text editor's contents of the window. So here's the entire slideshow program I'm using here to present to you. So that gives you the whole 9p overview. Now what do you do with, so how do you actually put things together? Well, typically a Plan 9 network has several machines. You've got a terminal, you've got a CPU server, you've got a file server, and you've got an auth server. So, oops, wrong slide, wrong direction. So the terminal is just a dumb terminal, local device access. Draw term, which is what I'm using to remote into that system, is basically that. Flick it off, walk away when you're done. There's nothing important on it. It's a dumb terminal. CPU servers basically serve compute power. Remember, they don't do any process migration. You have to manually start a program on the CPU server and it stays there until it quits. There has been talk of automatic migration, but it's been talk, not implementation. The discussion has had a distinct lack of semicolons. The file server stores data. Historically, it's ahead of the curve on snapshotting, but the rest of the world's caught up. And the auth server basically manages user accounts, secret keys, etc. Yes?
When you say server here, do you actually mean physical machine?
Physical machines. You can run them all on one machine if you don't have that many. So that laptop's running basically everything it needs to locally. But you can assemble a network out of multiple machines. You can have multiple CPU servers and so on. And basically what you're doing is you're pulling resources. Hey, I want that machine's keyboard. Hey, I want that machine's user list. Hey, I want that machine's file system and that machine's file system. And then Factotum is basically your user like SSH agent. It's nothing too special. And that's basically your secret management stuff. So basically, you can post things into a network by gluing things together with namespaces. Seamless access to remote resources. It falls out of the whole model. The way that you administer and use the system, it basically comes for free with the unified model. Now, of course, this has a cost. Because everything is so general, you can't really do special hacks like send file, which assumes local file descriptors and so on. The generality isn't free, but the composition is. Okay, so I'm going to skip going through our CPU because I feel like we've been taking long enough. Actually, I'll just show you roughly how long it is. This is the script that you actually use to remotely log into a machine. The core of it is really just mount. I've been talking about namespaces and binds. Basically, all it does is go to this machine, take this thing's devices, put them on top, and you're done. Cool. So that's that. Anyways, that's it. you've enjoyed your bit of OS necrophilia. And yes.
I do smoke tests for Perl, and I believe that at some point in the past, Perl was supported Plan 9, but we haven't had a smoke test result in many years. So I'm wondering if you have any information on the usability of either Perl or other dynamic programming languages.
There is Python that ships with the system.
Really old Python,
Yes.
2.5 something.
Yes. There is a 2.7 that's been ported, but really Python's only around because people want Mercurial, which I am working to kill. So the idea there is that we're hopefully going to just move that to ports and get rid of the base system Python. There is a Perl port from 2003, I think, and that is, I don't think it's been touched since. I would be interested in seeing someone update it, but yeah, most of it's just RC and there's Python shipped, but no one really seems to like it. Go is actually, it's not really a dynamic language, but it is supported and is ported. There's,
By,
by
the author? Who
yes, yes, I believe the author, or I don't know if it was the author of Go, but there's definitely a Go port that's actually maintained and up to date. And then there's an OCaml port that happened recently. Okay.
For some reason, every time I look at like the way that you can edit the real environment, for some reason it reminds me of a Smalltalk environment. It's dynamic, ever changing, like you can update it right there on the fly and the changes will apply more or less immediately. I mean, when they were developing Plan 9 and Rio, I mean, like, did they look at Smalltalk and say, hey, this is a pretty awesome idea, let's do this?
So this is actually not Rio, this is Acme, which is the text editor. Rio is the window system around the editor. But if you want to, so the inspiration for the editor was not Smalltalk, but it was Oberon, which is Nicholas Wirt's system. Basically, he started doing the dynamic text stuff, and Rob Pike kind of looked at it and went, I like that. I'm stealing it.
It does remind me a lot of Smalltalk, where it's implemented. It's basically changed an aspect of the environment. It takes place immediately, and you can just get right to using it.
Yeah. So Oberon is really the place that came from here.
So, sorry to add on really quickly.
Go ahead.
Are there other languages available on Plan 9 besides like the ones you mentioned, Perl and Python and Go and OCaml?
C.
That's about it?
My language is ported. There are a couple. Do I have ports on this system? I mean, I think I do.
What's your language?
Meridian.
Sorry, what was it?
Meridian. I'll type it, actually. Let me just type it up here.
There's also C, FTGBC.
Yeah, so that's my language.
Meridian.
Meridian, yeah. Oops. Undo, and here is... Okay, so not too much. There's a tickle port, and so
Smalltalk?
Where?
Squeak.
squeak. Oh, there is a squeak.
Close enough.
Huh.
So it's still Smalltalk.
Yeah.
Neat.
Which means it's very structured.
Yeah.
Can
So
you
it's
read
not
those
a.
aloud? Can you read those aloud?
Yeah. Yeah.
For the blind?
So there's Fortran to C. For all those Fortran programmers, Go. Go 1.4, which is used for bootstrapping, and a wrapper around it that pulls in Go 1.4 and then builds in US Go bootstrap. There's Lua, there's Meridian, there's OCaml, there's Scheme, there's Squeak, which is Smalltalk, there's Tickle, and then there's Tiny Scheme. The Perl port is not in this list. It does exist. It seems to work. Someone used it for porting Git actually fairly recently. So the upstream Git, not my re-implementation. Yeah.
Did Rob Pike write a language called Squeak?
Yes, I don't think this. Oh yeah, new Squeak. Yeah.
I think an early slide showed Nix as a fork of Plan 9? Is that?
That is a different mix.
Oh, is it?
There is a fork of Plan 9 that is experimenting with scheduling. So what Nix does is basically trying to, it's Plan 9, but with the idea of having a kernel core and application cores. And
You're saying that's not the Nix that
that's
I'm
not,
familiar with?
probably not.
Okay.
They were doing some interesting stuff where basically the idea is that you can have cores that the application only runs on top of, and the system calls go to the kernel of the CPU, which is not going to affect scheduling. And the idea behind it was, as the CPUs start to have 64, 128 cores, you're going to have enough that all the busy applications can just consume a core to themselves and don't need to be scheduled. So if something needs to happen, it's going to be super low latency. And that was coming out of the high-performance computing world. So IBM, I think, during that era, was doing a bunch of research on supercomputers with Plan 9. Yes?
First, for a long time, I was not interested in Plan 9 because it seemed like you needed to use a mouse. But now I see that it's very powerful to be able to click on things.
Yes.
So it's making me want to, it's making me reconsider.
But you want to pick up the mouse?
Yeah.
No, on Plan 9 for the mouse to be useful. But if it was on Plan 9, maybe the mouse would be useful suddenly. Now I'm wondering, of course the issue is that not like all the software I use isn't going to work. It very well, yeah. So I'm wondering if there's an easier way to deal with this problem. Currently I have like one main computer, and then anything that I've given up on porting to that computer, I run somewhere else in my SSH.
Yep.
So for example, for a time I had it that, now I got the scanner working, but for a time I had it that I would SSH to another computer. I had a program, like let's say I call it scan image, and that would log into another computer and run scan image on the other computer, and then give me the result back.
Yep.
Or like Inkscape running on another computer to communicate with Templar. So
Yep.
is there, if I'm doing that, is there a better way to plan on doing that than doing the exact same thing?
I mean, you can SSH and do things directly. Like I've just SSH'd into my OpenBSD box. You can do SSHFS, which mounts SSH. I mean, you're still talking to a Unix system, so there's only so much.
So it's Fuse support, or?
No, I mean it's SSH. It's 9P.
It's not. It's a different SSHFS.
Yeah, it's a different SSH client.
Right. It's Plan 9. Everything's a server.
Yeah.
As opposed to everything's a file. Right.
Yeah, and basically, I mean, Plan 9. If you thought OpenBSD reinventing the wheel was bad, Plan 9 kind of takes it to the next level. You know, we've got our own SSH with our own SSH implementation. That was another Synapse project. I think it took a week or two, and it's 1,500 lines of code.
Would you or have you run a public box on the internet with Plan 9?
I have not. I might, but there are public boxes, I believe. SDF. There's also 9grid, where basically there's a shared file server. Someone's giving out free accounts to whoever asks, I believe. And
Which is the fork you're using?
I'm using 9front.
9front.
Yeah, the front fell off.
What about, I mean, what I'm actually most curious about is I mean, I know the origins and the devs who are, of the developers involved in the beginning. Are any of them still involved? Or is this just like?
Let me see if I can find the FQA really quickly. Frequently questioned answers.
I didn't know this kid. I'm like in shock about that. I had no idea this kid was. I didn't know they did videos.
Yeah, so, by the way, that gives you an attitude of the developer.
Everyone knows him on that formats.
Okay. So section 1, Plan 9 is not for you. Just to emphasize it, in case the start of my presentation was not enough. Let's go back up. This is not the fastest network. I'm tethered through my phone, so actually, Why did Plan 9's creators give up on Plan 9?
I can't read either.
Yeah, I'm waiting for the pictures to load. There are pictures. The text itself is way too small.
I see a contrast in colors.
Yeah. So for the people that can't read, I was your pilot. Basically, the people that were working on Plan 9, Bell Labs died, they stopped getting a salary, and they went on to work on other things, mostly at Google.
When they went to die at Google, yeah.
The preferred phrase, I believe, is went on display.
Sipped Kool-Aid went on display.
Yeah. So basically, yeah.
So Google's where bad folks go when they die. It's like a fire and fry.
It's the best recruiting tool Google has.
To be fair, it was like Ken Thompson and Rob Pike working on Plan 9, then went to Google made the single videos.
And that's it,
Yeah. Well, Ken is now I believe, fully retired.
Yeah.
Yeah, Ken is retired. I did see Ken though earlier this year at Vintage Computer Fest. Grumpy old gray beard as usual.
Of course.
He comes a few times a year.
Oh, nice.
It said he fired up Plan 9 on a Pi not too long ago.
Sorry?
He fired up Plan 9 on a Raspberry Pi not too long ago.
Oh, nice. Yeah, so Raspberry Pi with AMD 64, or sorry, not AMD, ARM 64 support just landed in Plan 9, I believe, at the end of August.
Doesn't Inferno still have a
Or
not?
I don't know.
There's a port, but it's not really updated.
Sorry, port for what? I missed that.
Inferno, the operating system, yeah.
For the Pi.
So the Raspberry Pi was interesting to watch happen, mainly because the Raspberry Pi 4 is ridiculously complex, and the bug that really caught people for a long time. By the way, feel free to just go talk amongst yourselves, because at this point I'm just telling stories. But basically, what happened, the bug that really hung things up for a few weeks was the Raspberry Pi would work, and then randomly some Ethernet traffic would happen, and all interrupts, everything would freeze for exactly 42 seconds. And then it would resume.
Which Raspberry Pi?
Pi 4.
It's not sharing the bus anymore with USB and everything else.
No, it's got real Ethernet.
Okay.
So So sitting there debugging, trying to figure out everything that's going on, trying to get people at Broadcom to give some hints and so on and so forth, and eventually they kind of, after enough banging, they figure out exactly what's happening. If you walk off the end of executable memory, you end up getting, well, the bus kind of goes wonky long enough for a 100 megahertz timer to tick over 32 bits, which is 42 seconds. Now, none of the memory accesses that they were doing were wrong, so they were looking over that with fine-tooth comb. But it turned out that the memory had been mapped in the page tables with an executable bit. So what was happening was the CPU was going, okay, you're running along these instructions, let me prefetch the next ones. And that fell off the end of the executable of valid memory. The bus kind of went, ah, my head's on fire, and the whole thing locked up for 42 seconds. Eventually, the timer wrapped around, and everything started working again. And it turned out that they had actually thought of this initially, or the porting people had initially thought of this, so Synap. But there was a typo, misread of the documentation, I'm not sure. So he was setting the wrong bit on the page table. So, yeah.
So has anyone, or do you think will anyone be masochistic enough to try and port this to the RISC-V architecture?
Compilers have to happen first.
So I think
But
why not compiler? I can see somebody can port to
Windows 5 recently.
Yeah, I think there was. Yeah.
I don't know, but they added it within the Planet ecosystem. Like the changes they added.
Okay. So then it's possible. I think Richard Miller was doing some stuff around that. I'm not sure. And Charles Forsyth is usually the compiler guy, so he might have done stuff too. It's probably buggy because nothing's really using it at the moment. But if it exists, the bugs can be fixed and someone can do a port. It's just a matter of someone wiggling fingers.
I'm intrigued by the point about Go. Now I'm thinking, everyone seems to like Plan 9, and everyone seems to hate Go. What should we make of this?
Nobody relies on Plan 9 in production.
Nobody uses Plan 9. Everyone uses Go. I'm sure that a lot of people will hate Plan 9 if they had to actually use it. You had a question about that.
Did Acme always support different size fonts and different windows?
Yeah. Yeah, sorry. I probably should have been changing the fonts more, but it was a bit annoying to switch them around. So you.
Yeah, sure. We're talking a lot about the words and the fonts being clickable, but I think I guess I'm worried that I can't tell what's clickable and what isn't. Like there's no like UI. What does that mean? Like if you click on a word that doesn't correspond to, what if you click on the word like your up in there? Like when is the past name?
Oh, let me see your. I don't see your, so let me just type it.
Yeah, sure.
Okay, so you can right click and nothing, and it'll just search for the next one. Middle click will just do nothing. You might be able
to put RM in there or something like what?
Oh, RM will delete it.
What about LS or something?
Ah, sure.
Okay. Like it just seems like there's like a lot of potential unintended consequences from that.
It's like a terminal.
Yeah.
It's not like a terminal. I mean, you could accidentally do something.
I could accidentally hit enter on my terminal.
Yeah.
All right.
Don't point the loaded gun at yourself.
Okay, so we went over the languages that are available in Plan 9 or available for Plan 9.
Yeah.
So let's get to the next subject, which is porting software to Plan 9. How easy or how difficult or how pulling and seam is it to bring any kind of software over to Plan 9, whether it's Unix, Windows, Mac, whatever, to Plan 9?
Windows isn't happening.
Well, I know Windows isn't happening, but like I guess like anything like maybe POSIX compliance. I mean, does Plan 9 have POSIX compliance in it?
It has an emulation layer, yes.
Okay, so if I bring anything POSIX compliant to Plan 9, how easy would it be to just compile it and run it in Plan 9?
There's a chance it'll work. It depends on how much the surface area you use is. So, for example, there's no mmap. I believe the closest that we do is if you try to mmap something. A lot of places will do a read-only mmap, which you can just emulate by doing a read of the data, and with malloc, and then read it instead of mmap. There is, well, none of the software that's been ported so far has needed pthreads, so there is no pthread support, at least not in 9front. There are patches floating around that implement pthreads, so if someone actually tried porting stuff, I would be happy to import pthreads into 9front.
So I guess like anything that doesn't really need any kind of wacky system calls in another Unix or Unix-like operating system should generally be okay to run in Plan 9, yes?
Yeah. Yeah.
Okay. So it's like if I wanted to do like I'll throw this one up in the air. Let's say like if I wanted to do like Vorbis tools, for example.
Oh, I think we have those.
You have Vorbis tools?
Yeah. Augink and so on.
Augink, yeah.
Yeah, those are there.
All right. What about like flat P code or flat P code?
Got it.
All those too?
Yeah.
So anything that's like, I guess like that doesn't need any kind of wacky system calls or any kind of wacky libraries will run okay.
Yeah.
If I compile in Plan 9.
Yeah. Now the one that we would like, which no one's actually done yet, is FFmpeg. That one, I believe, there's a bunch of assembly that might need to be forwarded. But I think someone's started looking at it. I'm not sure what the status is. I don't think they finished looking at it.
So on that note, since you mentioned FFmpeg, let's try maybe, I know VLC is probably out of the question, but let me say mPlayer. Something simpler. Something a little bit simple.
I wonder if that. Well, first off, you need the codecs.
Yeah.
Those are the hard part, I think. mPlayer, you'd probably want to write a new window backend.
Yeah.
But
I mean, like, even if you called it from the command line, because I know you can do that with mPlayer. You can call from the command line, say like mPlayer run, this file name, and it launches it in a simple window.
Not sure. Might be doable. The other thing that we'd like to do is, I mentioned that you can run VMs. I mentioned that X11 has recently been ported. The goal that I'm hoping we can eventually get to is something kind of like Windows Subsystem for Linux, where basically you have a Linux kernel sitting beside the Plan 9 kernel in an emulated environment, and whatever hooks are needed to make it not suck using it.
Yeah. So I guess like you can almost be like it almost sounds like what you're saying is like almost like the BSD jails.
Yeah, kind of, I guess.
Yeah, like kind of like have it sitting there in its own little contained environment. You call it when necessary, call it to run like an application, and then just like once it's done, just say okay, go back.
Yeah, something like that. And you had a question.
My question is about 9P protocol.
Yeah.
So I see like every communication to the system is based on its network protocol, right?
Yeah.
So that makes me wonder like then we introduce all the problem of this distributed systems via this network unreliability, right? So
yeah.
How does this? I mean, does 9P handle it in some any different way or?
No. If it dies, reconnect. There's a tool called AAN, which is basically kind of like Screen, but for TMUX, but for 9P instead of for proper sessions. And that'll kind of transparently just stall the connection and try reconnecting periodically until it starts working again. I believe it does some stuff to tell everything to redraw, reinitialize its stuff if you lose the connections, but I'm not entirely sure.
Kind of like a TCP.
Yeah, but there's nothing magical in there.
Are you using Plan 9 port on the OpenBSD machine to talk to the 9 port machine or some other?
Drawter.
Okay.
Which is not Plan 9 port. It's basically it's kind of a Plan 9 kernel and user space that has just enough in it to mount a 9P server and run the shell script that it uses to import the stuff from that machine and pull it and do the drawing.
It's a tiny follow-up question. Are you just using that on all machines? Like, do you have to use for Plan 9 port at all, or do you just get enough mileage out of that existing Plan 9 songs?
I use Plan 9 port for a few utilities, but not too much. The main one I use is the plumber. So in my terminal, I can right-click on a URL or an email and open stuff up from there.
Another nice thing too with bullet term is that it mounts your local file system to that namespace on that CPU server that you're running in it. So you could open up an active session with bullet term and work on your local files. Okay.
Sam.
Or play audio files. Over network points. It works.
Do you see Plan 9 like, 5 or 10 years from now being a sort of more adopted, or is it always going to be a kind of, academic exercise?
Sorry. I'm actually slightly sick. That wasn't a sarcastic comment on purpose. It was just well timed.
Yeah.
Okay, so basically, I don't see it taking off in any commercial sense. I think it's basically going to be same niche as haiku, maybe. People like the system; they'll probably keep using it. They might use it for personal stuff. Maybe one crazy company will try to do something, but probably not. Unless I started and try and do it on purpose.
Your own startup.
Yeah, but I mean, you could hire the entire user base of Plan9 and still not have enough people to actually fund it or to staff a reasonable sized company, I think. So I don't see it. I see that alone as being enough of a barrier.
It has been used commercially because we have someone on the mailing list who used to work as a lawyer and he ran his law firm. He told me, I don't know if it's true. He said he ran his law firm on Plan 9.
There are a number of places it's
They're
been
on
used.
talk?
No, it just not on talk. He's on talk, but this was not on talk.
So there are a lot of places have used it commercially in the past, or a lot. There are places that have used it commercially in the past. For example, there was a startup called CoRaid, which was built on that. There is the Cisco PIX routers. You might notice the PIX is Roman numerals P9. So they were based off of Plan 9.
How? What does that mean?
They took the Plan 9 code, hacked it up like hell, and used it as
The
an
old
event.
PIGS platform?
Yes. Yeah.
I didn't know that.
Yeah, that was Plan 9. At least initially. I'm guessing that at some point Cisco rewrote it, but that's a guess.
I always thought the old all the Cisco OSs back in those days, iOS, and so on, the real
Yeah,
iOS.
well,
they were all BSD based. Thought they were all System 5 or BSD
Possible.
stripped out. Looks like.
So PIX was actually acquired by Cisco. So yeah, I'm guessing at some point after acquisition they kept the brand, but
So pre-Cisco.
yeah.
First one.
Cool. Anyone else have? Yeah.
Your comment on using Plum and Plan 9 port is interesting to me, because then maybe I can start using something else without installing Plan 9.
I had to patch my terminal to make that work, but
Which terminal?
ST.
Well, I just see.
Okay. There might actually be a patch floating around that's better than the one I have. I'll look around. Okay. Anyone else have questions? Or? Okay.